Hi, Algebra 2. In Chapter 11, Lesson 1, here we're going to be graphing sine and cosine. Here we go. To define a periodic function, it's a function that repeats exactly in regular intervals called cycles. Now that cycle can begin at any point on the graph of a function, so it doesn't have to just start at like the y-axis, for example. The length of a cycle is called the period, and that's why it's called a periodic function. You can see in the example here that we can measure a period from a maximum to another maximum, a minimum to another minimum, or in the middle, in the midline to another midline. This function is not periodic. Although it's going up and down, it's not going up and down exactly the same every single time. Function A here is periodic, and it's periodic because it does repeat exactly. And our length of our period here, we can see, I'm going to start here on the y-axis. Remember, we don't have to, but if I go to the right, I'm going to notice that I get to the exact same spot again in a distance of pi. So the period in this one is a distance of pi. Function B here is not periodic, although it does appear to have some symmetry, and maybe if we could see more of the graph going left and right, it might be periodic, but from what we see here, it's not periodic because the right side of our graph is higher, it goes higher than the left side of our graph. It doesn't repeat exactly. Function C here is not periodic. It does not appear to be repeating from the part of the graph that we see. Function D is periodic. It is repeating exactly, and the period length here is 3. And I'm going to use this point right here. Again, you can use almost any point when you're trying to find the period length. And I'm going to go to that next repeating point right there, and we can see that I went from -2 to 1, which is a distance of 3. This slide is similar to an activity we did in class when we were graphing sine and cosine. Because sine and cosine repeat as you go around the circle over and over and over again, it is going to be a periodic function that will keep repeating. The amplitude of a periodic function, sine and cosine function, is going to be half of the difference between the maximum and minimum values. So we're going to find the maximum, find the minimum, and divide that in half. A couple of reminders with your sine and cosine function. First, looking at the sine function right here. The period is 2 pi. I could start right here at the origin, and when I get to the next point where our pattern is repeating, I am now at 2 pi. You can see pi right there being halfway. The amplitude is 1, and we can see that distance here. This is 1 from the midline, from the x-axis to the highest point. It's also going to be 1 from the x-axis down to the lowest point. In the cosine function, your period and amplitude are the exact same. The only difference here is that the cosine function is shifted so that at the x-axis, it's not going through the origin. It's going through the point 0, 1. So looking at different ways we can transform the graphs of sine and cosine, the amplitude in your equation is always going to be this number that's multiplied out in front of sine or cosine. The period, you're going to use b right here to do that. Now, the period is not actually b. The period is 2 pi divided by b, whatever that number is. And then if you are adding or subtracting something from x, you're going to move it right or left. And if you're adding or subtracting something on the end, you're going to move it up or down. These two pieces are very similar to what we've seen with other transformations. This example says that we're going to use f of x equals sine of x as a guide. So what I did here is I sketched in sine of x with the gray dotted line. And then we're going to graph the function g of x equals 1/2 sine of 1/2 x. And first we need to identify the amplitude and the period. So looking at our function, the 1/2 that's out in front, that is our amplitude. So that's going to tell us that this is going to be shorter because currently sine of x has an amplitude of 1. The period, this says, is we're going to use b, which is 1/2, but to find the period, we're going to take 2 pi divided by 1/2. Now, dividing is the same thing as multiplying by the reciprocal, so this ends up being the same as 2 pi times 2, which is going to be a period of 4 pi. So now, instead of a full cycle happening in a period of 2 pi, The full cycle now is going to happen in a period of 4 pi, so it's going to be very stretched out. So here we go as we graph this. We're still starting at the origin, and we're going to end here at 4 pi. That means the halfway point is going to be 2 pi. Now in between 0 and 2 pi is going to be pi, so that's going to be at an amplitude of 1/2. So it's going to be much shorter. And then at 3 pi, we're going to be an amplitude of 1/2 again, and that's going to be below the x-axis. So we see this shorter, more stretched out sine function happening. When you're graphing these, I like to remember where you're starting, where you're ending at the end of your period, halfway between that, and then also halfway between those intermediate points. Here we're going to use cosine x as a guide, so I have sketched that. The difference here is that we're starting at 0, 1. We still have a period of 2 pi. According to our equation, the amplitude of our new function is going to be 1/3, so it's going to be much shorter. And the period is going to be 2 pi divided by 2, the 2 coming from right there in cosine x, which simplifies to just pi. So now, instead of it taking a whole 2 pi to get through one cycle, we're going to do that in just 1 pi, so it's going to be shorter. So again, remembering when we're starting and ending. So we're still going to start at our y-axis, but now it's going to be at just a distance of 1/3. The cycle or the period now is going to be just pi. So at pi, I'm going to be back at that 1/3. So now halfway in between there is where I'm going to be down below the x-axis at -1/3 for my amplitude. And halfway in between 0 and pi over 2 is going to be pi over 4. That's where we're going to hit the axis, and again at 3 pi over 4. So then I can go ahead and draw this, and we could continue and draw another cycle on our graph as well. Subtracting pi over 4 from x inside those parentheses is going to move it to the right, pi over 4 units. So just like other transformations we've had where left and right feels opposite from what it should be. So if I use the sine of x as a guide, I drew it there in gray, I can just move every point to the right pi over 4 units. So I've done that and connected the points that I have, and the rest of my graph I can just kind of estimate a little bit there. I really encourage you to have both graphs drawn here, the gray sine of x and then the purple sine of x minus pi over 4, so that you can really see that shift to the right. I've drawn our cosine of x guide in gray, and we're going to shift all of this to the right pi units. So I'm going to take each point and go to the right pi units. I've extended out my graph from 2 pi to 3 pi just to make it easier to go to the right pi units. So I've moved all of the points that I have to the right pi units, and then I can go back and fill in my graph over here, and I can see that I can actually finish out down at -1 on the y-axis.